So over to you.
I'm also going to go sans microphone because my lab will be able to tell you why I do that. So, hello, my name is Scott Rich. I'm a postdoctoral research fellow. I'm working with Dr. Francis Skinner and the star of that great video we saw, Dr. Tawfiq Valiente. And my research uses computational neuroscience to get at the underlying mechanisms of seizure initiation. And already I said something that might be a little sort of weird and sciencey, and that's this term computational neuroscience. But all that means is that I use interdisciplinary techniques to approach neuroscientific problems in new and different ways. My doctoral training was not as a neuroscientist, it was actually as an applied mathematician. But what that allows me to do is use techniques and perspectives and tools from not only mathematics, but the other associated fields to attack neuroscientific problems in these different ways. And one of the things that computational neuroscience can do that sometimes pure biological neuroscience can't do is get at the mechanisms underlying neural dynamics, to get at the how of the question, not necessarily just the why. And where this gets into epilepsy is that this sort of holy grail of epilepsy research is what causes a seizure? What is the underlying mechanism that starts off a seizure? If we know that mechanism, we have distinct, clear targets that we can look at from a clinical point of view to try to stop the seizure from happening before it happens. And that's obviously the best outcome for a patient with epilepsy. So, not only is my computational background making me sort of unique in doing this research, but our lab has sort of taken a new and novel perspective on epilepsy as a whole. And to explain this, I'm going to make an analogy between our brain and a car. Now, I want you to imagine is that a seizure in your brain is basically like if this car all of a sudden went off careening at high speeds for no discernible reason. That's more or less what happens in the seizure in your brain starts firing and it goes super crazy and we don't know why. Now, for hundreds of years, and we've known about epilepsy for literally hundreds of years, the overarching theory has been that there's something wrong with the accelerator pedal that causes that seizure. And if you took your car to a mechanic and the mechanic told you this, you'd be inclined to believe that because that's a somewhat intuitive explanation as to why your car might go super fast without warning. But not surprisingly, our brain is not as simple as a car. And a lot of new experimental evidence has shown us that something a bit unusual might be happening when it comes to seizure. And the analog is if I slammed down on the brake of my car, and that's what caused the car to go careening off at 100 miles per hour. And yes, I said miles per hour, it's not American. So, what we want to do is we want to use that computational perspective to not just get at why this is happening, but how it's happening. Because it's so unusual and because it's so unintuitive, it's all the more important that we understand why this is happening. You would not want to get back in that car unless your mechanic could explain what actually happened because it's so unusual. And by getting at these how questions, we're going to be able to come up with new and innovative techniques to actually approach seizure and help patients.